Alright, hello everybody. Welcome to lesson 7.5, Write and Graph Exponential Decay Functions. This is the final lesson in chapter 7, where we have been discussing exponent rules and exponential functions. In this particular lesson, by the end of the lesson, you will be able to write a function rule for exponential decay functions. You're going to understand the difference between exponential growth and exponential decay. You'll be able to plot points to graph an exponential decay function, and you will be able to solve an exponential decay word problem. Now, one thing that you will find is that this lesson is very similar to the lesson we did in 7.4, so you want to make sure you check those videos out. But this series of videos here, the processes are all very the same, but the primary difference is whether something is growth or decay. The actual process will look the same for everything. However, we want to know the difference between growth and decay. So first of all, let's just draw a line down the middle here. Right on this side, we'll talk about growth, and on this side, we'll talk about decay. Obviously, let's just make sure we know what the word means. Growth means increasing, and decay generally means decreasing. In general, we can apply something to make it so that's not totally exactly the same, but in general, growth means increasing. For positive functions, growth means increasing and decay means decreasing. Okay. Both of them have the same formula, which I'm going to write here in the middle. Y equals a times b to the x, right? I'm writing that in the middle because it's shared by both of them. Yeah, it's the same formula. The a value still equals the starting value, and the b value still represents the growth rate. The difference in a decay versus growth is that the growth functions will have a growth rate of 1 or greater. If this b value is greater than or equal to 1, or I should also mention less than or equal to -1, then you have a growth function. And a growth function will look like this. When we graph it, it'll look something like that. Okay? Remember, this is repeated multiplication, just like we talked about in the last lesson. The decay function will have a different b value. The growth rate for decay is going to be between 0 and 1, and I really should make it between -1 and +1. In other words, it's a number between -1 and 1. And a decay function will look like this, and we'll do some examples of this later on. But a decay function, see how it has that same kind of curve? It's just instead of curving up to the right, it curves up to the left. Okay. Some examples of the growth would be like 2, 2.1, 1.5, right? These are all b values that make growth. Or even like -3, right? B values that might make a decay problem are going to be like -0.75, 0.5, 0.25, 1/4, etc. Numbers between -1 and 0, and I just realized that I should fix something here because this should not be or equal to, wop, wop, because it doesn't include -1 or 1. Okay, that's better. So that's where we're going to end this video. There's some questions on your canvas that will ask you to identify a function, whether it is exponential growth or decay. We will go over those questions in the next video.